Here's your homework solutions for tonight. A particle moves along the x-axis given by that velocity. The particle is at position -5 and 0. So you can see the type of question, right? It's a particle in motion question to do with velocity and acceleration. All right. Step number one, I'm going to put that in my calculator right away so I don't have to retype it in. So I'm going to go menu. Let's go back again. I'm going to go press the shaky calculator part. Let's go to graph. Then go menu, actions, and delete if you have anything. And then press tab and then type that in. So I'm going to go control divide. And then I'm going to type in 10 sine. And it's 0.4. Again, I'm going to use x. So x squared. And then in the denominator is x squared. Subtract x plus 3. All right, double check. Did I do a good job? Press enter. All right, now I don't have to type it in ever again. It's done. Now I can look at the question. So it says find the, and I might answer it right in here. Find the acceleration of the particle at t equals 3. Acceleration is the derivative of velocity. So you take the derivative at 3. So how would I do that? Menu, calculus, derivative at a point. X is our variable. It's at 3. And then all I have to type in is that f1 at x. I don't have to type all that ugly. And then go control enter. And at 3, it's negative 2.118. There are no units in this question. Done. That would give you a point. Find the position at t equals 3. So the position given, the particle is at position -5. Start there. Plus integrate. It starts at 0, and I want to know what's the position at 3. And then integrate the velocity doing that. So again, it would be -5 plus menu calculus, integrate, and it goes from 0 to 3, right? That's what we're doing. Yeah. And again, our velocity is just f1 at x. dx. And isn't it nice to type it in once, right? So it's negative 1.760. Evaluate from 0 to 3.5 the velocity and evaluate the absolute value of that and then interpret the meaning of both. So this is displacement. This is total distance. So type that in your calculator. So that answer, if you type it in, menu, calculus, integrate. Again, from 0 to 3.5. Our velocity is f1 at x. And you get 2.843. That's the displacement or the net distance from t equals 0 to t equals 3.5. The second one, do that above. Again, we're going to go menu, calculus, integrate from 0 to 3.5, but this time we're going to use the absolute. Now the absolute value bars are here, so look to right beside the 9, press the button to the right of it, and then find the bars right there on the left, press enter, and then type in f1 at x, dx, and you get 3.737. That's the total distance from t equals 0 to t equals 3.5. So one is total distance and the other is displacement or net distance. A second particle moves along and that's the position of it. At what time are the two particles moving with the same velocity? So let's type that in. Oops. I'm literally going to go here. I'm going to press tab. So now f2 is the second particle. It's going to be x squared. Subtract x. Make sure I typed it in right. Come back here. So when are the two particles moving with the same velocity? So when are they equal to each other? So it's a solve question. So I'm going to go menu algebra solve. The first velocity is just f1 at x. Subtract. Now the second one's going to be the derivative. So menu calculus derivative of f2 at x Oops, I want to know when they're equal to each other, not subtracting. Hope this works. If not, we'll take the derivative and we'll do it a different way in a second. I'm going to see if it works. When are they equal to each other? I get 1.571, which is what it is. So 1.570. So ultimately, you took the velocity of 1 equal to the derivative of the second, and knowing when does this equal each other, and the answer was when t equals 1.570 is when the velocities are equal to each other. Great job. Hey, only 6 minutes. Mr. G Math over and out. Till next time, I'm proud of you for doing your homework.